The universe is expanding. Objects in space are moving farther and farther apart, increasing the size of the universe and the space between everything. But wait, how do we know this from our vantage point here on Earth? Listen to that car horn. As it comes towards us, it has a really high pitch, but it drops as soon as it passes us and flies away with a low pitch. This is due to the Doppler effect, which, as we'll get to later, is the same phenomenon that allows us to know that the universe is expanding. So let's break down how this works. Sound, like the honking from the car horn, travels in waves. Imagine these hula hoops here are wave fronts and my foot is the car. If it's at rest, the wave fronts are equally spaced in all directions. But if I slide my foot forward, representing the motion of the car, the wave fronts in front of it are compressed and the fronts behind it are stretched out. So when the car is moving towards us, we're receiving the compressed sound waves at a high frequency and consequently at a high pitch, while we receive lower frequency and lower pitch sound waves when it's moving away from us. Doppler shifts have many practical applications just here on Earth. Police radar guns, for example, shoot waves at a moving vehicle, which undergo a Doppler shift when they bounce off it. This phenomenon can be used to calculate the speed of the vehicle. The same concept applies to evaluating the movements of clouds when predicting weather patterns, and for measuring the speed and direction of blood flow in the heart. But how does this apply to objects in space? Well, light waves, just like sound waves, undergo the Doppler effect when emitted from an object moving towards or away from the observer. But when light waves change frequency, instead of changing pitch, like sound waves, they change color. Take a look at the visible light spectrum. Shorter wavelengths create blue light, while longer wavelengths create red light. So when an object is moving towards us, it undergoes what we call a blue shift, where its emission spectrum shifts towards the blue end of the visible light spectrum. An object moving away from us has the opposite effect, undergoing a red shift. Looking at this more closely, the emission spectrum I'm showing is for hydrogen and helium, the elements most commonly found in stars. Each element has its own emission spectrum, and the emission spectrum for a star is a combination of those for the elements that it's composed of. When a Doppler shift occurs, the pattern remains the same, but it shifts to the left or the right, and we can use this observation to analyze the star's movement. We can even determine the velocity of the moving celestial object just using the ratio of the original wavelength of light emitted to the wavelength after the shift. It's incredible how much we can learn just from these shifts. Astronomers have discovered a significant amount of faraway objects in space undergoing red shifts, thus signifying their movement away from us and from each other, providing evidence that the universe is, in fact, expanding.